Hello and welcome to my YouTube channel. Today let's write a Python program to check whether the given number is a prime number or not. This video is the continuation of the previous video. In the previous tutorial we talked about prime numbers and how to check whether a given number is prime number or not. Today we are writing a Python program to implement that. Okay, to write the program what we need to do is first we need to take the input. Here input is a integer number. And we need to check whether that number is prime number or not. And the second step is if input number is greater than 1, then check whether it has any positive divisors other than 1 and itself. If the input number is less than 1 or equal to 1, then that is not a prime number. So no need to check for the positive divisors. So first we need to check whether input number is greater than 1. If it is greater than 1, then we need to check whether given number has any positive divisors other than 1 and itself. To do that, what we need to do is we need to divide the given number starting from 2 to till that number, or we can divide that number starting from 2 to square root of that number. I explained this logic in the previous tutorial. The link of that video is in the description box. Then if it has any positive divisors, then write the message it is not a prime number. If it doesn't have any positive divisors other than 1 and itself, then we can write the given number is a prime number. We need to follow these steps. Next, let's write the program. First, let's take the input. So we are using input function. Write the message, enter a number. And as I said, we want integer number. So use int function. Here num is the variable which stores the user entered input number. Next, we need to check whether the entered number is greater than 1, because prime number is a natural number which is greater than 1, right? Remember the definition. So if a entered number is greater than 1, then only I'll check whether this number has any positive divisors other than 1 or itself. If it is not, if a number is equal to 1 or less than 1, then I'll use else block for this if condition, and I'll print the message not a prime number. So inside this if, we need to check whether the given number is prime or not. Only when this condition is true, we'll check whether that number is a prime number or not by finding its positive divisors. For that, we need to divide the given number from different numbers, like starting from 2. If our number is 5, 5 divided by 2, 5 divided by 3, 5 divided by 4, like that. We need to do that. So for that, I'll use for loop, and here I'll divide the number starting from 2, because 1 is the positive divisor of all the numbers, and prime number is a natural number greater than 1 that has no other positive divisors other than 1 and itself, right? So no need to check for 1. So we'll start from 2 till you can take till num, that is if my number is 5, then I'll see whether 5 is divisible by 2, 5 is divisible by 3, 5 is divisible by 4. Here no need to check for 1 and that number itself, that is 5, because prime number can have 1 and itself as the positive divisors. And here if number divisible by I, if I divide the given number by 2 or 3 or 4, we need to get the remainder as 0, then that number is a positive divisor of given number. So we can write like this. If this condition is true, that means the given number has positive divisor other than 1 and itself. So I can print this message, number is not a prime number. Then what I'll do is I'll execute break statement. Why? Prime number can have only 2 divisors, right? 1 and itself. When I find a positive divisor other than 1 and the number itself, I'll print this message and I'll come out of the loop. I don't want to check for other divisors. What if we didn't find any positive divisors? Here we are excluding 1 and the number itself. We'll check for other positive divisors. If we didn't find that, what to do? You can use else block with for loop. What this else block will do is, if this for loop is not terminated by the break statement, then it will execute else block. When this for loop will terminate by this break statement. That is when we find a positive divisor other than 1 and the number itself, when the number is not a prime number. If this statement is not executed, that means that number is a prime number. It doesn't have any positive divisors other than 1 and itself. So here we can print this message, number is a prime number, like this, and we are done. So let's save this and execute this. Let's enter 15. 15 is not a prime number. Let's enter a number 1. 1 is not a prime number. 29. Okay, so what is happening here? Let me explain 3 scenarios. When I enter number as 1, it will check this condition first. 1 is greater than 1, false. So this condition become false, so it will execute else block. So we'll get this message, 1 is not a prime number, and done. Next scenario, when you enter num as 10. So 10 is greater than 1, true. So this condition becomes true. So it will execute for loop 2 to num. Here num is 10. So 2 to 10. Initially I value is 2. Number is 10. 10 modulo 2 is equal to 0. True. This condition becomes true. So it will execute this. That is, number is not a prime number, and it will execute this break statement. So control will come out of the loop, and we don't have any other statement to execute here. Program ends here. If I enter 3 input, 3 is greater than 1, true. So this condition becomes true. It will execute if body for I in the range 2 to num. So 2 to 3, we'll get I as 2. If number modulo I, that is 3 modulo I 2 is equal to 0, no, it is not. So control will again go here, but we don't have any range to check here, I value to check. So control will come out of the for loop. Because this for loop is not terminated by the break statement, it will execute else block, and here we'll get this statement, 3 is a prime number message. Okay, this is how this program works. Next, as I said previously, instead of dividing the given number till num, what we can do is we can check till square root of this number, right? So what we can do is int of num. To use square root, I'll use this operation, power operation, and I'll use 0.5. Then plus 1, because if I take number as 25, I need to divide the given number till 5. So that's why here you need to include plus 1, because here end is exclusive, right? That's why. So instead of dividing the number starting from 2 to 24, what we can do is we can divide the number starting from 2 to 5. If we get any positive divisor in that range, then that number is not a prime number. If we didn't find any positive divisor, then that number is a prime number. So here, let's save this and execute this. 25. 25 is not a prime number, true. 123 is not a prime number. 167 is a prime number. Here what we are doing is, to find the positive divisors, we need to divide the given number starting from 2 to till that number, right? It is a long process. To shorten this, what we can do is, instead of dividing the number till that number, we can divide that number till square root of that number. To find the square root, we are using this power operation. And square root of number is not always an integer number. To convert that to integer, we are using int function here. Here you can see an example. This is about prime number program, how to check whether the given number is a prime number or not. So that's it for now, guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.